In this video, we're going to be talking about proportional parts of triangles. When triangles are intersected by a line that is parallel to any one of the sides, so in this example, this line is parallel to the bottom, but we could have drawn a line that was parallel to the right side or a line that was parallel to the left side, it doesn't matter. It's basically this just rotated in a different direction. So anytime a line that is parallel to another side of the triangle cuts that triangle, it cuts it up into proportional parts. And here are all of the proportional parts. The first thing we can do is compare the left pieces to the right pieces. So we can set up proportional parts that compare the top of the left side to the bottom of the left side. And then we could set that equal. It will be proportional to the top of the right side compared to the bottom of the right side. So just comparing corresponding parts. We could do the same thing, but we could talk about the total of the left side compared to one of its pieces. So if I compare the total left side to just the bottom piece, then I would have to set that equal to its proportional parts on the right side. So what corresponds would be the total of the right side, RT, to the bottom of the right side, TA. And then we could do the same thing, but talk about the other smaller piece compared to the total. So I could take the total left length or piece and compare it to the top piece, so RI to RO, and then I would set that equal to its proportional corresponding piece on the right side. So the total of the right side, RT, compared to the top piece, RA. To go further and define some more proportional parts, it's easier if we just separate these triangles and look at them separate. So if I take this top triangle, this top smaller triangle, and then compare it to the total triangle, we can actually come up with a few more proportional parts. Let's see if I can get it all on here. So I want to compare RO to RI. So the smaller piece on the left compared to the total, that would be equal to the smaller piece on the right side compared to the total. So RA to RT. It's one we already talked about, but here's the new one. Take a look at the bottoms. So because we're talking about proportional parts, those pieces are also proportional to the bottoms of the triangles. So this length OA compared to IT, or OA to IT on the bottom if we separate it. So that's the trickier one. Other than that, it's basically just comparing corresponding pieces. Now the reason we're able to do this is because we have two similar triangles. Here's one way to think about how these triangles are similar. I know that in both triangles, whether I'm talking about the smaller triangle or the bigger outside triangle, angle R is going to be the same in each triangle. It's not changing. So we know that angle R is going to be corresponding and congruent. Here's the trickier one. If we take a look at this left angle, angle O down here, it's corresponding to angle I down here. If we think about parallel lines and the types of angles that are created when two lines are parallel, that's that corresponding angle relationship. So those two angles are also congruent. So we have two angles that are congruent, two corresponding angles that are congruent. So these triangles pass that angle-angle similarity test. And that is why these proportional parts are working. So let's see how we can use that. Given an example where we got to solve for an unknown measure, we're going to find the measurement of y here in this example. So a lot of different ways we could do it. Just as long as you're comparing corresponding pieces, we could set up proportions in a lot of different ways. I could compare this piece to this piece. So 3 to 6, as long as I compare it or set it equal to y to 8. We could go across the triangle. I could say that 3 and y are corresponding. They're the smaller pieces. And I could set that equal to the ratio comparing 6 to 8, those corresponding pieces. We could also get fancy not necessary, but we could compare 3, or this piece, to the total length on this side of the triangle, so 3 to 9, and say that's equal to y to 8 plus y, the total length there. That would be the trickiest or fanciest way to do it. Not necessary. Any of these previous two proportions work just as well. So to solve a proportion, cross multiply and solve, and so we get y equals 4. All right, let's do another example. In this case, we're going to solve for x. Lots of different proportions we could set up. We can compare this piece to this piece, so 8 to x plus 5. Set it equal to the corresponding pieces down here on the bottom. That would be 6 to x. We could do it another way. We could go across the triangle and set up those proportional parts. So 8 to 6 is equal to x plus 5 to x. And we could cross multiply and solve that. Or one last thing we could do is set up a piece to the total length. So 8 to 8 plus 5 plus x, or x plus 13, the total length over there. And then set that equal to 6 compared to the total length would be 6 plus x. Again, fanciest way to do it and totally not necessary if you can figure out these other two proportional parts. So to solve it, cross multiply either of those and solve for x. So we get x is 15. All right, here's an example where we do need to compare the total because that would be the value given. So we can set it up saying I want to compare this bottom piece to the total. So I got 8 to 12. So I need to make sure and set that equal to what corresponds over here on the other side. That would be 10 to x plus 10, the total over here. Or we could do a little bit of problem solving. If we know the total here is 12, and this much of it is 8, that must make this 4. So now we can ignore the total and set up some easier proportions. So I could say 8 to 4 is the same as 10 to x, or I could say 4 to x is the same as 8 to 10. So lots of different options. As long as you're comparing corresponding parts, there are lots of proportions that work and will help you solve for the variable. So if we solve any of these for x, we should get x is 5. So that's proportional parts of triangles. Again, just make sure that you're comparing or setting up ratios that compare corresponding parts, and you should be able to solve for the variable.